I want to thank everybody for coming today. We're going to go ahead and get started. I'm just going to do a quick brief introduction and then turn it over to the experts here. So this is Amanda and Mustafa.
Yes.
With ConnectGen, which is a renewable energy company that develops wind, solar, and battery storage projects around the United States. Amanda is the project manager for the Railtie Wind project under development in southeast Albany County, which is what they're going to be talking about here today. So,
Thank you. Yeah, thanks so much to the university for inviting us to come speak. As Tammy said, I'm Amanda. I'm a project developer with ConnectGen. By the way, if you can't hear me at any point, just like gesture that I need to speak louder. Yeah, front row seat.
There would be more people that would want to go.
It's fine. Yeah, so I'm a project developer. As a project developer, I'm involved in pretty much every aspect of getting a project from an idea to being ready for construction. So that's, signing land leases, doing all the various environmental studies, going through the permitting, community outreach, selling the power to a customer. I am very much a generalist, not a specialist, but I enjoy the fact that I get to be involved in, sort of every aspect of the project's development. So just brief overview of who we are. ConnectGen, we develop renewable energy projects all around the United States. That includes wind, solar, and battery storage projects. Map of where some of our projects are located. So for today's presentation, I'm going to be talking about our Railtie Wind project that ConnectGen is developing pretty close to University of Wyoming down in southeastern Albany County near tie siding. And I guess more generally I want this presentation to be kind of like a wind development 101 sort of thing where I'll be using Railtie as an example, but we'll kind of generally walk you through, what goes into developing a wind project. So just some background on this specific project. Like I said, it's located near tie siding on either side of Highway 287. It's about 26,000 acres, mostly private land, 80% private land, the rest is state land. The land is all currently used for cattle ranching, which will continue alongside the wind project. We are planning to use up to 120 wind turbines across the project area and are aiming to start construction. I think most likely at this point we are planning to start construction spring 2023, and we'll have the full project operational by the end of 2024. And when we picked this project location, we initially started looking across the entire state of Wyoming and narrowed down on this site for a number of reasons. Obviously, you guys live here, the wind is excellent. So that was pretty compelling. There's also an existing transmission line that runs right through the project area. So that's the purple line that you see on this map. And lack of high voltage transmission has been a big obstacle for wind development in Wyoming. You'll have these really windy areas, but you'll have no way to move the power anywhere. So the fact that there was already an existing transmission line that was underutilized and had available capacity was very positive. And then also, we wanted to make sure that we were, developing in an area where we would have minimal environmental impacts. Any industrial project like this is going to have impacts, but certain areas of Wyoming are more sensitive than others. So we looked at things like, sage grouse areas and designated migration corridors, and located this project in an area where there would be, fewer environmental sensitivities. So for these next few slides, I'll go through, using Railtie as an example, the different aspects of wind development. So the very first thing that you need to do when you're developing a wind project or a solar project is get the land. So this was mostly private landowners. So we reached out to them to see if they would be interested in hosting a wind project. Once they indicated their interest, we entered into lease negotiations with them. So that was negotiating, the payment terms, the protections for the landowners under the lease, and getting to a place where, they were comfortable entering into this long-term commitment with us and, becoming a partner in this project. And actually, Chris was one of the attorneys representing one of the landowners. So we got to work with him kind of on the other side of the table for signing one of the leases. So that's kind of a funny coincidence. Yeah, and so we went through, for the private landowners, it was, working directly with those landowners. For the portion of the project that was state land, that went through, the Office of State Lands and Investments. They had a, formal application process that we went through to get that wind lease. And for these ranchers, they view this project as, a way to kind of diversify their income. Ranching isn't always, the most lucrative business opportunity. And, looking long-term, it's kind of challenging for them to keep this land intact and in their family. So for them, the wind project was a way to, continue ranching, keep the land in their family, but also have this other source of income that can keep them viable. The next category I'm going to touch on is outreach. So this is something for any project you want to do early in development, you want to reach out to, local and state agencies, environmental NGOs, and just learn from people who know about the state, know about the project area, and see if there's anything, any sort of fatal flaws or issues that you should know early on when you're developing the project. So that was something that we did, in the first couple months after identifying this project. And then, as the project became more, concrete and advanced into these permitting processes, those all had public engagement opportunities as well, where there was public comment through the various county and state permitting. Next category is wind analysis. So wind developers today have it pretty easy compared to wind developers 20 years ago, and that there are these really excellent nationwide models that show you basically anywhere across the US, what the wind resource is expected to be. 20 years ago, if someone was trying to find a good spot for a wind project, they would literally look at a map and be like, oh, this road is called Windy Road. I wonder if it must be windy there. Like they really had no other resources. So even though we do have these tools now, we still need to verify, in fact, that these national models are correct and that the wind resource is what they say it is. So that's another thing that you do early in development is you install wind measurement equipment across the site. So that can be shown here, what's called a Met Tower, 60 to 100 meters tall, with anemometers on different levels, and you'll measure the wind speed, the wind direction. What's becoming more common now is called remote sensing equipment. And that's actually a device that's, ground level, about the size of a large printer. But it uses, there's two different types. Some use light waves and some use sound waves. And they can measure wind speeds up to 200 meters above the ground. So that's pretty cool. And another benefit of those is, once you put these Met Towers up, that's kind of where they are. The remote sensing equipment, you can move them throughout the site. So that's starting to become more widespread, but for financing purposes, still like to see the Met Towers just because they're a little more tried and true. So most wind developers do kind of a combination of both to measure and understand the wind speed. Oh, one last thing here, electrical studies. So I mentioned for rail tie, there is a transmission line, runs right through the project area that we're proposed to interconnect to. The operator of that line needs to make sure that the project, a 500 megawatt project can interconnect to the grid without causing, stability issues on the whole system. So they go through a series of increasingly detailed electrical studies to determine what equipment is needed to interconnect the project and if there are any upgrades needed on the system to accommodate that project. So this next category, environmental, is a big one for wind and solar development. Something else, you know, I keep saying, want to start early, but this is another thing, we want to start early. For wind energy projects, the U.S. Fish and Wildlife Service has wind energy guidelines for wind developers to follow on baseline wildlife studies to do. So they recommend a minimum of 2 years of these baseline studies for large and small birds, raptor nests, eagle nests, and bats. So that's something for Railtie we started back in early 2019, since completed those full 2 years. Also, for Wyoming, they have certain species that they've identified as species of concern. So for species where it looked like there could be potential habitat in the project area, did species-specific surveys for those. You know, environmental, I think most people immediately think wildlife, but it also includes other categories of things as well. For example, you know, wetlands and water resources. We did surveys and delineations of those water resources across the full project area this summer. And then also cultural resources. So that can be anything from, you know, a stone circle from a Native American camp, or, you know, a foundation from an old homestead. And so this fall we went out and did pedestrian field surveys identifying any cultural resources that exist in the project area. All right, so this category, regulatory approval, is something that will vary project to project, you know, depending what state you're in. Some states only have local permitting, some only have state permitting. If you're in Texas, they don't have either. You can pretty much just build anything. It's kind of crazy. So Wyoming is a state where there's both local level permitting and state level permitting. And then for Railtie specifically, there was an additional federal approval. And that was actually because the transmission line that we're interconnecting to is owned by the Western Area Power Administration. They're a federal entity, part of the Department of Energy. So that brings in this extra level federal review. So the federal is the lengthiest. We started that in very beginning of 2020 and are expecting to conclude it end of this year, early next year. So about 2 years to get through that process. And then the state and the county, we went through those permitting processes earlier this year and received both our county and state approval this summer. All right, so a question I've gotten, you know, from some people locally is, you know, you've got your county and state permit, you must be done and, you know, done with development and ready to build, but we still got a bunch of work to do before we can start construction. Kind of outlined it at a high level here. As I mentioned, we're still working through the federal approval. Really now kind of we're shifting from development sort of to pre-construction. So that's when you get really focused on, you know, the engineering, the constructability, getting a very detailed design and figuring out the best way to, you know, both in a cost efficient way and a safe way to actually build this project. So where someone like Mustafa starts to get very involved. He's one of our pre-construction managers. You know, what we'll do before we start construction is do geotech borings at every single turbine location to determine the subsurface conditions and engineer the foundations. We'll be doing, you know, detailed boundary surveys of the project area, micrositing different project infrastructure. Yeah, and then, so ConnectGen, we're the company that develops the project, but we're not the ones that build it. This is a pretty standard model for wind development. So we'll bring in a general construction contractor who will, you know, who's built many, many wind projects across the country, and we'll contract with them to actually execute on the construction. And then what else? Oh yes, we have to buy the turbines. That will be, you know, a pretty big check when we do that. That's something that we'll do, you know, before we start construction. And then another, you know, big final piece of the puzzle is securing a customer for the power. So the way that renewable energy projects typically sell their power is through a long-term contract that's called a power purchase agreement. And so this is usually, you know, a 20-year long agreement where the customer can be like the utility, and the wind project will agree to a set price for the term of that contract. And typically utilities like to make sure that a project is, you know, real and is actually going to happen before they will enter into that contract. So now that we have, you know, secured our county and state permit and are close to finishing the NEPA federal approval, we've gotten, you know, a lot more serious interest from customers, and are, you know, looking forward to hopefully, you know, announcing, you know, contract for the power, you know, in the next few months or so. But that's something, you know, to be clear, we cannot build this project unless we have a customer. There's not going to be any scenario where we put the project up and no one wants the power. All right, so these last few slides, just high level of, you know, why we think this project is a positive for Albany County and the city of Laramie. For one, it's going to generate a ton of new tax dollars for the state and the county. Wind projects in Wyoming actually pay 3 separate taxes. There's the sales and use tax. Most of that's paid during construction. And then there's the excise tax on wind generation, which is a Wyoming specific tax that they have on wind. It's, you know, $1 for every megawatt hour of energy produced. And then also we'll be paying property taxes on the value of the wind equipment. So when you total all of those up, it ends up being, you know, about 4.2 million per year over operations, of which 3.3 million would go to Albany County. So that's during operations. And then during construction up front, that's kind of when the biggest chunk comes from all those sales and use taxes. And that'll be about 27 million during construction, of which 14.6 will go to Albany. Another benefit is job creation. During construction, there'll be a couple hundred construction jobs over the full span of the construction. And those are temporary jobs, but, you know, those construction workers will be staying in Laramie, eating at Laramie restaurants, and helping, you know, drive local business during that time. And then during operations, there'll be about 23 permanent employees to operate and maintain the wind project. All right, yeah, so at this point, we'll open it up for questions. So you already know who I am. This is Mustafa, Debbie sitting right here, and then Preston. I forgot to take this picture off. He actually just learned yesterday that he needed to head back home tonight for his daughter's marching band banquet, so he wasn't able to make it. But yeah, I'm happy to answer questions. Yes.
So I got a question. By the way, we got a real good turnout of students in our federal lands class. And so we go over NEPA in our federal lands class. Usually when we're talking about NEPA, it's application to federal surface or federal minerals. And my question for you is, you know, what's the NEPA process been like? You know, we're dealing with private land here, but there's a federal connection. And when they're looking at the environmental impact, you know, what is the look? Are they looking at the environmental impacts on the private surface? And so just an overview for our students, I think, would be really helpful.
Yeah, you're right. Yeah, usually when, you know, projects are subject to NEPA, it's because you're building on land that's owned by the Bureau of Land Management. So this is a little bit unique. And for this project, WAPA's only direct involvement is the interconnection switchyard, right? You know, where the project plugs into their power line. But under NEPA, the wind project is considered what's called a connected action. You know, unless WAPA grants this interconnect, we wouldn't be able to build the project. So they have to look at the impacts of the project as well, even though it's on private and state land. So so when they put together this environmental impact statement, it does look at the entire wind project, even though it's not on federal land.
And what's the timing been for NEPA? You said you started early in the process. We talk with our students, you know, some NEPA analysis of various energy projects can be, you know, everywhere from 2 years to 20 years. So just very curious on, you know, give that perspective on private land environment. What does the length of the NEPA process look like?
Yeah, so we first started kind of like, I guess, coordinating with WAPA probably early to middle of 2019. And so at that point, they, went out and got a third-party contractor on board who would actually prepare the EIS. And then, NEPA officially started when they published their notice of intent. I think it was like, second to last day of like 2019. So there's public scoping at the beginning of 2020. They spent almost a year putting together the draft environmental impact statement that came out this spring. There's a comment period. They held some public hearings, virtual because of the times, on the draft EIS. And then they took all of those comments and incorporated them, where applicable, into the final EIS, which should be coming out, we're told, end of this month. And then once the final EIS is approved, there'll be, a waiting period, and the record of decision, which is kind of like equivalent to the approval, would be released probably January, February 2022. So all in, it's a little over 2 years from start to finish of the public process, at least. Which, yeah, as far as NEPA goes, isn't that bad.
Yeah,
I've heard of, taking a lot longer, and it kind of depends on, who you're working with. Fortunately, we've got a pretty good team at WAPA that's able to, dedicate time to this. You might be working with a BLM field office where they're stretched really thin, and they just, literally don't have the people and resources for this large of an endeavor. So it can really vary.
Thank you. I think that's hopefully very helpful. You guys have follow-up questions?
I was going to ask what part of the NEPA process you're in. I also had a question on when you were thinking about having a project in the high area, was the railroad in the area, the railroad access in Laramie and all that area, a big portion of deciding that to haul equipment and turbines on railroads rather than on the semi? I assume that's probably quite a bit cheaper.
Yeah, it played a factor. So certain turbine components you have to do it, crossroads. The turbine blades are just too long to put on a train. But certainly the nacelles, some of the top tower segments will probably be able to use the rail. Some people have asked, since the railroad cuts right through the project area, are we going to be offloading in the project area? Unfortunately, no, we would have to build, a ton of infrastructure to be able to do that. But, the fact that there's rail yards in Cheyenne and Laramie, good infrastructure nearby for, actually, delivering these components and getting them where they need to be.
I guess, generally speaking, what are like the private landowners entitled to like compensation? And then is that like fixed based, like just an annual thing, or is that like a variable based off energy output? Yeah, so there's the development term, so that's like the period we've been in now, and the landowners get a certain dollar amount per acre fee while we're developing. But then when the project operations start, that's kind of when the bigger payments kick in. So it's kind of structured so they will be getting a royalty payment, a percentage based on the number of turbines they have on their property and how much energy they're producing year to year. So it is kind of flexible or variable based on how much wind is there going to be that year. But we also have in our lease like a minimum payment. So let's say like there is a really bad wind year, or there's some sort of issue, like their turbines need maintenance and they're not operating or something like that. There is a guaranteed minimum payment that they'll get every year. But in a typical year, the royalty payment should be much more, and that's what they would be paid.
Just going off that, what do you think about Wyoming saying that you can't sever the wind from the surface? Like you can't say I'm going to convey to you the wind, keep the land. You can't sever them. What do you think?
Yeah, so I think that used to be allowed in Wyoming. Is that right? Yeah, because there was a project in a landowner in a different county that we were talking to where they did have the wind rights separate from the land rights, just because they'd done it back in the day and had been grandfathered in, which was the first time I'd actually come across anything like that. That was kind of a new concept. I think, I don't know, I mean, I'm used to dealing it where you can't sever it, so that's just kind of the status quo.
Just to know if it provided something in the process that would be a lot easier to develop. And maybe better or different. Yeah,
I'm not sure. Yeah, haven't really dealt with it that much.
I'll make one point, and this kind of might go to your question. In oil and gas and minerals, we often have separate estates, which Caleb was getting at, where you might have a lease, and then you got to go do a surface use agreement with with the surface owner. And so, maybe you can give a little bit of background in your lease agreement. These are pretty lengthy agreements that have a lot to deal with surface. So really only kind of have one agreement.
That's right. Yeah, it's a single agreement that covers, our rights to capture the wind energy, but also like to build roads, collection lines, travel across the property. So yeah, I guess I would imagine if the wind rights and the surface rights are severed, then you would have to do 2 separate agreements, maybe double the work. So probably from a development perspective, it's easier to just have it tied together.
Does ConnectGen do any solar, and if so, where?
Yeah, we do solar. Should I go back to our map?
Yeah, while Amanda is looking at that, we are doing solar in New York, we're doing in Texas, we're trying to do it in Illinois, California, Washington, all over the place.
Good. Yeah. Thank you.
Yeah.
Once you're up and running, how long do you think the project?
Yeah, so we're planning for a 35-year operational life. And then at the end of that lifetime, we, will look whether it makes sense to like repower the project. That's something you're seeing with some of the older projects in Wyoming right now, where they're installing the latest turbines. Or if for whatever reason there's like some brand new clean energy technology 35 years from now, then we would just decommission the project and reclaim it.
In that case, how would you dispose of them?
Yeah, so it's hard to predict what will happen 35 years from now. For projects being decommissioned today, the majority of the turbines are recyclable, all of the steel, copper, etc. The fiberglass blades, unfortunately right now, really the best thing to do with them is to put them in a landfill. Positive side is
as a matter of fact, and there are new technologies that just released this year.
Yeah. So, the good news is that blades are completely inert. Once they're in a landfill, they're not going to release any sort of, it's not the same kind of concerns you have with fossil fuel waste by any means. But yeah, it does, take up space in the landfill. So there is, fortunately, from environmentally minded people, a lot of pressure on the wind industry right now to figure out how to make the turbines completely recyclable. And there's been a lot of progress, a lot of new technologies in the last few years. A lot of the manufacturers have now publicly made commitments that they're going to be recycling all their blades by a certain deadline. So unless things completely go off the rails there for some reason, I feel very optimistic by, for Railtie, 35 years from now, this project is decommissioned. The blades will be able to be recycled.
I've heard that some of the research has involved different sonic type things for the blades, and also different colors that deter birds.
Mm-hmm. Yeah, so I think maybe one of the studies you're referring to, there was a study with a small project in Europe where they painted one of the blades black, and the results were very promising in terms of seemed like pretty cost-effective, simple way to minimize avian collisions. So unfortunately, it was just one study at a relatively small project, so it needs to be replicated a bunch more before the industry makes any sort of movement. But love seeing that those kind of studies come out.
Who owns the electricity that's coming out of these turbines, and then how is that sold or marketed, or whatever, you like package the offsets, like how is that going to work, or do we know that yet?
Yeah, so we'll enter into a long-term power contract, likely with, you know, a utility.
Sure.
So we would sell the power to them, and then they would, you know, balance that power with the rest of their generation portfolio and supply energy to their, you know, residential, commercial customers, etc. And typically, you sell the energy and the renewable energy credit together. Sometimes you'll sell the renewable energy credit separately, but then the power is considered like brown power. It's not considered green energy. So usually the easiest way to do it is you're selling the energy and the environmental attributes together to one customer.
How does that work for selling offsets? Like, would it be the sort of brown power if you're like selling to, say, a firm in, you know, Washington, D.C. or something that's like, they're not getting our electrons, right? Like the lines aren't there yet.
Yeah.
How does that work exactly? And would that be like, is that a common use case for utility like we would see here, or would that be not something that we see?
That's not as common, at least in my experience, but yeah, it is possible where, you know, sometimes you'll just sell the environmental attributes, the renewable energy credits, like directly to a company that wants to offset its footprint. And then maybe there's a utility that doesn't care as much about, you know, having renewable power, so they'll just take, you know, the discounted ground power. Like, even though it is, you know, wind energy still, but it doesn't have that, you know, credit of being renewable.
Your leasing and permitting process, do they include any maintenance clauses or something to say where you have to continue to keep your project at a certain par of or floor of maintenance standards throughout technology advancements?
Yeah, that's pretty typical for leases, that you don't have to keep the project in good working order. And then actually, if I'm remembering correctly, the state of Wyoming requires that, you know, if the project isn't operating for some reason, I can't remember if it's like a year or 2 years, but if for some reason the project isn't operating for a period of time, you have to decommission it. You can't just leave the turbines up.
Are those going off that, are those 23 permanent employees, are they like strictly mainly maintenance, or what would those permanent employees?
Yeah, it would be mostly wind technicians doing, you know, maintenance, inspections, you know, several supervisors, like site management.
Yeah. Asset management, because those landowners needs to get paid. You need to pay for the bills that are due. Yeah.
It says here in your sheet that you guys have seen the potential for drinking water contamination.
Oh, that's not our sheet.
Yeah. Oh,
some people here decided to pass that out, but so yeah. If you have a question about it, I can try to
answer.
I do.
I was just going to say, what are some of the steps you guys are taking to potentially stop that?
Of drinking water?
Yeah.
Yeah. So one of the conditions of our state permit was that if we, you know, one of the concerns people had was that if blasting is needed for, you know, any of the turbine foundations, that could have impacts on some of the nearby water wells. So as a condition to our state permit, for any locations where blasting is required, we're going to identify any water wells within a mile of that blasting and do both pre-construction and post-construction testing. And if the post-construction testing does reveal that, you know, somehow our project interfered with the quality of the water well, we would then be on the hook to mitigate those impacts. So that's one way that we're working on that.
Is there any kind of monitoring for like wildlife collisions, is that a thing that's like a part of this project or any other projects like in the States? I know it tends to be like patchy and there's a lot of arguments about like the impact of that specifically. And it seems like I get the sense that the industry as a whole doesn't have like a cohesive way of like monitoring that, especially when a state like this protein that's on the ground will disappear. So you can't really check once a month because there won't be any evidence left of the collision.
Yeah, so there is, you know, post-construction monitoring of mortality. You know, both the U.S. Fish and Wildlife Service and Wyoming Game and Fish have, you know, methodology for those types of surveys. And yeah, you're right, they're not gonna catch every single mortality.
Sure.
So, they'll have to kind of statistically extrapolate, if we actually found, these many carcasses, like for this amount of time, kind of extrapolate out to estimate what the actual mortality was.
How often is that like a continuous thing? Like which office is going to do that?
So it's something that, we would hire someone locally to do that.
Okay.
For all the wildlife surveys to date, we've been working with West, awesome Wyoming company, and they'll likely do those surveys as well.
Okay.
And then we would share that information with the Wyoming Game and Fish. And Wyoming Game and Fish, they have, it's called a technical advisory committee. And it's actually kind of unique to Wyoming. I haven't really found this in other states where when projects have to create a committee where it's, the project company, the Wyoming Game and Fish, and then also any of the private landowners who want to be involved. And they meet minimum once a year once the project is operating, and look at the survey results and figure out, if there's any like adaptive mitigation that needs to be done based on the surveys.
So in our federal land law classroom, over the Endangered Species Act, I know that Albany County is home to the Wyoming toad, which is an endangered species. Was that the issue that came up with you guys? Studies you wanted to choose Albany County? Did you have to go about finding an area that wasn't a direct impact to them? How did you guys go about that?
Yeah, so we worked with Wyoming Game and Fish early on, based on the habitat in this area, what are the species of concern that could be expected to occur here? So the toad was not one that they identified for this area.
How does the pre-construction phase vary between like a solar project and a wind project? Yes.
So yeah, in the pre-construction side for both, you still need to procure equipment.
Turbines versus panels.
Exactly. You still need to finalize your engineering design. You need to do your geotechnical investigation. So yeah, in the pre-construction side, it's pretty similar between both sides. It's just you're dealing with different challenges. Like in the wind side, you're dealing with how tall the turbines are and how to make sure that this is not affecting any radars in the area, stuff like that, where this is not really a challenge for the solar farms, stuff like that. In solar farms, for example, you need to acquire more land because it's spread horizontally. But for the wind projects, you don't have to worry about it that much. Each one of those fields has its own challenges. You need to hire an EPC contractor, you need to procure equipment, you need to basically build both projects. So, yeah.
I think we can all assume there will be some blasting with rocky Wyoming geology. I'm not sure the veracity of this, but some folks are talking about subterranean waves, as in fault lines and stuff like that. Has there been much research into those concerns?
Yeah, so the blasting for this project, if necessary, would be very small and controlled.
And we're trying to.
Yeah, it's not like when you're like at a quarry, you're trying to blast like this huge hole. It's like, you just want to loosen the rock in this very specific area so you can dig it out.
And we are doing our best to avoid those areas whenever it's possible.
Yeah.
In order to
we'll have to, once we identify, like if there is blasting and we identify the locations, we'll have to put together a blasting plan to look at, safety and those sort of concerns.
I don't think we have any existing serious faults in this whole area of the Rockies, at least up here around Wyoming. But it's been mentioned by some different circles, so it's a little bit fantastic kind of thinking, but you never know.
Because there's like the quarry right there off of 287. They do a bunch of
Right,
blasting.
Way more blasting.
Yeah.
Than what will occur in a project like this.
I'll remind the people that mentioned this to me about that. I kind of forgot about that. I actually have a friend that works out there with
Yeah.
large equipment.
Yeah, but I mean, totally, like, you know, with these kinds of huge projects, people are gonna have questions and concerns, and that's totally valid, so.
And as an engineer, I know that explosives has come a long, long way in decades from very directional kind of stuff. And so that's good to hear that you think about that. Thanks.
This is kind of a, I don't know, we probably don't have a definite answer for this because projecting into the future, but I'm just curious about how you perceive the new nuclear plant that's going to be in Canberra. Like, how is that going to impact this? Because that is going to be an extremely efficient energy generation source. And I mean, it's a practical concern as you're trying to market your energy as this is coming online. So how do you negotiate that situation?
Yeah, I mean, we don't really see ourselves as competing with nuclear. Nuclear is incredibly expensive. I mean, maybe there'll be some sort of federal incentives that will help nuclear be more competitive. You know, personally, I think, you know, all of the above, we need like all the solutions possible to get to a clean energy economy. But yeah, I mean, even if, you know, Wyoming is successful in hosting a nuclear plant, there'll still be, you know, plenty of demand for wind and other renewables as well.
Does ConnectGen do anything with nuclear?
No, yeah, okay. That's way, yeah.
Not that I know of.
That's pretty specialized. And not much new nuclear has been built in the US lately. Yep.
You list storage as some of your other projects. Any plans on putting some storage wind facility? Because as you know, often when the wind is blowing, electricity is cheap. But if you could store some of it and sell it when electricity is expensive, you can make a lot of money.
Yeah, so we're not considering storage right now. Maybe down the road it'll make more economic sense. For ConnectGen, we're mostly considering storage with our solar projects. And that works really well because, you know, solar is going to generate, you pretty much know what time every day solar is going to generate. And you're in situations in states like Arizona and California, where they have a ton of solar already, and it all comes online at the same time, and it all goes offline at the same time. And that's, you know, becoming harder for utilities to balance. So if you can have a storage system that will, you know, soak up some of the excess solar energy in the middle of the day and then discharge it in the evening when the sun is setting, you know, really helps balance the system, makes a lot of economic sense. It's not as common with wind right now, but, you know, definitely see it being something we look at in the future.
So ConnectGen is doing a fair amount of research into storage.
Yes.
We have several solar plus storage projects.
Yeah. I know the Los Alamos, what do they call it? National Lab is doing a real lot of work. I've heard they're kind of the quiet leader in storage technology and research. So I didn't know if you connected with them at all. Of course, they're federal. They used to be military.
We don't do a ton of research at ConnectGen. We more, you know, we rely on the researchers to develop the awesome technology for us, and then we take it and we
implement that technology. Yeah,
cool. Thanks.
The potential energy to be captured at any given time by a turbine, how much is actually, or like what percent is actually captured and put on the grid?
So I guess you're talking about like collection line losses and that sort of thing.
Yeah.
Yeah, those are pretty minimal, maybe like 1% or 2%. Yeah, it's pretty efficient in getting it from, you know, energy from the turbine onto the electric grid.
And that's, of course, trying to minimize that as much as you can in design things.
Right. Yeah. Designing the collection system so you don't have like, you know, super long runs of collection.
Yeah. Very good.
Hey, what are some examples of changes in your development plan for activating public throughout the period? And yeah, like members of the public.
Yeah. So one of the things we did pretty early on was commit to using an aircraft detection lighting system. So that's something, you know, the red blinking lights for wind turbines are not very popular. So this system, it basically scans the surrounding airspace for aircraft and only turns the lights on when there's an aircraft nearby. So it's able to reduce the amount of time that the lights are on each night. So after we committed to that, the county and state actually ended up requiring us to do that anyway. So we would have done it either way. But that was one change that we made early on. And then also through the county process, there actually were some conditions that the commissioners came up with that we ended up accepting. For example, the existing, baseline turbine setbacks between residences and turbines in Albany County is 5.5 times the turbine height. So for this turbine, that's like about 0.6 miles. And the commissioners actually, after hearing from the public, they increased that up to a full mile, which in my experience is like probably the largest residential turbine setback I've ever, encountered. So yeah, so that was another, big change to the project that involved us having to, relocate a number of turbines.
I'll add on to that. In my experience is just my negotiation with ConnectGen, they were willing to talk with our client and move things around pretty far into the project, based on, how my client would be operating their land for ranching. So it wasn't, I don't think just public, but, just negotiation with landowners as well, at least from my experience.
Yeah, thank you for bringing that up.
The name escapes me now, but there's that really well-to-do guy. He was in railroads, maybe still is. I think he's out of Denver. He was talking about putting a lot of money into transmission lines. And again, the name escapes me right now, but very well-to-do guy. And I just wonder if you folks have done much futuristic looking at enhanced and expanded transmission lines to facilitate potential other facilities coming up and going.
Yeah, so like the current transmission system that we have in the US is not adequate. Like we need to build so much more transmission. Yeah, unfortunately, building new transmission lines in the US is really, really hard. If you're a private company, you have to get permission from every single landowner along the way. If you're a utility, you have access to eminent domain, but there's still other, permitting challenges. If you're trying to develop a transmission line that goes across multiple states, you need to get permission from every single state along the way. Familiar with the project where they had permission from 3 states, but the 4th in the middle, they couldn't get permission from. So the project just, I think if there's ever going to be like actual, overhaul of the transmission system, there needs to be like a more federal, like permitting process rather than this kind of piecemeal state by state, just because it's just like the regulatory environment is not realistic for developing large scale transmission lines.
As an engineer, I've had to survey in a straight line of the transmission towers. It's amazing. The parameters we had to go by hundredths of an inch sometimes to be very exact, and not just horizontal but vertical for the foundation. So it was really fun land survey work. Mm-hmm. Plus getting out in the outdoors, working there. Yeah, I forget the name of that guy, but he had pledged a real lot of money.
Was it Anschutz?
Yeah.
Yeah, Anschutz.
Yeah.
Anschutz, I think it was.
Yeah, so he's still going. He's been developing his Trans-West transmission line for like 15 years now.
Oh, good.
So I don't know. He's still saying it's going to happen. So I'm rooting for him.
Me too. And he's got the money to make it go.
Mm-hmm.
Kind of like Bill Gates with nuclear.
Yeah.
So fun fact on that, he's the richest guy in Colorado.
Oh, is he?
Yeah, he's the richest resident.
Thank you.
This question was more rude than 8 months. I don't really know how it works, but does is there a decibel that's created? Like, is there noise? I didn't.
Yeah. Yep. So the wind turbines can create noise. I guess there's 2 sources of noise. There's like the mechanical noise that's like the gearbox, the nacelle, like the pieces moving. And then there's also the kind of like whooshing noise from the blades. So that's something that Albany County regulates. Have to be below a certain decibel level at the non-participating property line. So as part of our permitting process, we have to put together an acoustic model that showed that we would be below that level. And then since we, might change our turbine type between what we permitted and what we actually build. We'll have to, update that noise study to show which, with our final layout and final turbine that we're complying with those noise limits.
Certainly create noise and that it's kind of concerning, but every time I've driven, I will not keep.
Well, when you compare between the noise on the highway and the noise coming from a wind turbine.
Or the noise of the wind.
Right, it's like, yeah, right. It's you're driving the Casper from here. There's a big wind field. It's like if it's wind's blowing, you're not going to hear it because the wind's hitting loud. Yeah, I just thought I'd never heard that there was a.
Yeah, unless you are really, really, really close to them, the probability of hearing them is pretty minimal.
I mean, for people who live there, you want to make sure it's not at a level where it's going to be disruptive or annoying.
I actually toured one of the big turbine towers up by Medicine Bow, and just the shaft, I guess you'd call it the power shaft as an engineer, is huge.
Switch gear.
Yeah.
Yeah.
And I was really surprised at the small amount of mechanical noise. But like you say, it was pretty windy up on top. It's quite a climb to get up there. It was really fun to do it. But yeah, I was really surprised at the minimal mechanical noise.
I still haven't ever been to the top of the wind turbine, so
you got to do it.
Yeah, they're getting a little more like strict about it now. Yeah.
It's easy to look up there and see that hub, and it's so much bigger than how you envision from the ground. I mean, you can stand up and walk around up in those hubs. But
it's pretty cool.
It's pretty amazing.
Especially walking on the nacelle.
Yeah.
Yeah.
Have you done it?
Oh yeah, I used to build those for 3.5 years. So yeah, it's pretty cool, pretty neat.
But on the mechanicals, there is such a big scale up there,
Oh yeah.
Especially that shaft. Being a civil engineer, I was very interested in that. So pretty amazing. Thank you.
Have y'all done? Have y'all been asked to do like either in advance or after results of surveys to do like amelioration for like flying animal collisions? And if so, like what do you deploy or what do competitors deploy to do that? Like now in the status quo, is it like camera systems or like, I don't know, frequencies that people can't hear to like deter migration through that area or whatever?
Yeah, so there's a lot of different techniques. Some, more successful than others. Some still studying to see how successful they are. Like for example, like if you kind of need like bat deterrence, will be like a certain frequency. Kind of case by case basis how successful those are. Something that's becoming more common are these like artificial intelligence, like radar based systems. So it used to be, field biologists would stand in an observation tower and look at a pair of binoculars and like spot a golden eagle and be like, okay, golden eagle coming this way, curtail this turbine. But now there are companies like Identify, where they use this, machine learning, all the fancy new stuff to actually be able to identify the species of bird and see if it's coming near the turbines and automatically curtail them. So, yeah.
Models.
Has ConnectGen deployed like any systems like that with existing or like planned with projects or like, or have they planned to do so?
Yeah, so we're planning for real-time to use Identify.
Great. Cool.
Yeah, and it's something, there's a one project in Wyoming called Top of the World, where it's kind of been like the test case for Identify, and it's been working really well there. So it's been good to see.
Not to go on and on, but folks haven't been up to one of the hubs, but it's amazing to look out and right around the hub, it seems like it's going so slow. But of course, the end of the blade speed is much more as it goes around. It's like, is it really that slow? But then you extrapolate, the speed on the end of the blade. Pretty amazing.
Yep. In your experience with these other projects, the company.
It kind of depends. So for the permanent employees, they need to be people who have gone through, a wind technician training program. So depending on where the project is, there might not be that program nearby. Wyoming has one of those wind tech programs at LCCC, which is awesome. You know, hopefully we'll hire a bunch of kids from there. And I know there's students, some are from Wyoming, some come from all over the US to attend that program. So we'll be able to recruit some of those. Yep.
But this is kind of a question that's going out of ignorance. But my understanding with the noise levels is it's not necessarily like the audible noise levels, it's like the pressure changes generated by the turbine blades. And so if you're trying to model, I mean, obviously you have lots of different computer projection models for this. But if you're trying to model for the acoustics and the pressure changes that are not really detectable in the computer, but then you haven't determined like which settle on a turbine model. It seems like there are a lot of variables that you're having to juggle at the same time as you advance the project. That's not entirely a question. I'm just thinking about the complexity of the project and trying to consider like how do you place a turbine, determine by like the sound modeling or the acoustics modeling, at the same time that you're trying to determine the type of the turbine, or do turbines not vary that much in terms of the pressure or sound generated model by model?
Yeah, there's not a ton of variation model by model. But yeah, you are right. And it is kind of an iterative process. This is true of like just wind development in general. You'll come up with the layout and then you'll learn about like some cultural resources and then you'll have to change that. And you'll learn about like, I don't know, like a wetland and you'll have to move that. So it is kind of like, yeah, it is like a bit of a juggle where you'll be like, micrositing up until the last minute. In the case with rail tie, at least, so we, did a model, a noise model, where we had assumed like the 5.5 times turbine height setback from residences. And now, the county's requiring a mile setback. So any turbines are going to be further from houses than what we had modeled. So, sound is a factor of distance. So in the case of this project, we can be very confident that the sound levels of the final product at nearby residences is going to be less than what we had modeled for during permitting.
We have time for one last question. Any takers?
You guys have any plans for any more projects in the state of Wyoming or in, I guess, the region in the coming future?
Yeah, so we have one other dot in Wyoming, and that's a project over in Albany County. That was actually the one I mentioned where like the wind rights and the land rights were severed. That one's very early stage. For that project, the transmission line we would interconnect to is already at full capacity, so we wouldn't be able to add any more power. So that's sort of kind of wait and see how things change and across the electric grid. But yeah, maybe we might add some other projects in Wyoming in the future, but don't have anything right now.
Just a quick add-on. The first brings up a good point. Anything offshore or anything else nationally?
We are not doing any offshore wind. Yeah, just onshore wind right now.
And anything more nationally than what the map shows, like hopeful locations?
Well,
you mean wind the project inside the United States?
Yes.
Yeah, we're trying to get some stuff done. California, Nevada, Illinois.
Yeah.
We're a team of about 40 people, so we can only spare ourselves so thin.
Yeah, thank you.
Yeah.
Well, I want to thank everybody for coming tonight. Thank you so much. And I definitely want to extend a big thank you for you guys coming and speaking with us today and sharing this information. So thanks again and have a great night.